Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question which is based on the some PNP transistor and Zener diode in which we have to find the some resistance value. So the question is in the circuit shown below, in the circuit shown below, the identical transistor Q1 and Q2 are biased in the active region with beta value 20. Okay, so basically one circuit is there. So first I will show you the circuit. This one is the circuit, okay, which consists of two Q1, Q2 PNP transistor, okay, two PNP transistor, okay, and it is operating in the active region and beta value is given 120. The Zener diode is in the breakdown region with a VZ value 5 volt and IZ. The Zener diode current 25 milliampere. If IL is 12 milliampere, if IL is 12 milliampere, this one is 12 milliampere. So we have to find the value of R1 and R2. Okay. Then the value of R1 and R2 in kilo ohm we have to find. Okay. And given the VEB1 and VEB2 is 0.7 volt. So first of all, we have to write the things what is given. So I am writing here the given thing. The both are operating in the active region with current gain 120. Diode, J diode in the breakdown region with VZ value 5 volt and the IZ value 25 milliampere. Okay, that we have discussed. And IL value is also given. The IL value across this RL resistance is how much? 12 milliampere. Here it is written 12 milliampere. So we will write the all given value, okay, and the value of VEB1, the voltage across the emitter base junction and emitter base junction for the second transistor Q2 is 0.7 volt. Okay, so we have to find the value of R1 and R2. So this one is the question. Okay, so these are the and the we have to find the value of R1 and R2 in kilo ohm, and these are the options 0.6 kilo ohm, 0.4 kilo ohm, 1.4, 2.5 like that. Okay, so first of all we have to start with this circuit. Okay, so very first we can say this end we can say the emitter end of 2. Okay, transistor Q2 which is basically a PNP type. So this one is emitter side, base side, and this we can say C2. Okay, and this one is what we can say PNP type. So we can write or okay, this one is also PNP, PNP type, in which this one is our emitter side, base side. So B1 I am writing, and this one is our collector side, C1. Okay, so in this case BEB1 is given 0.7 volt. This value is 0.7 volt. Okay, 0.7 and 0.7 volt. So, and this value is given VE2. VCC is 20 volt. So, what we can write from here, VEB2. Okay, VEB2 is given 0.7 volt. And this VEB2 can be written as VE minus VB. Okay, into. So, what we can write 0.7 volt equals to VE2. VE2 is nothing but simply 20. Okay, VE2 is nothing but simply VCC, that is our 20 volt. And VB2, we don't know this voltage, so this voltage we can easily find VB2. Okay, so VB2 is 20 minus 0.7. Why I will doing it will clear very soon. Okay, so VB2 is 19.3 volt. Okay, clear. So what we observe that this value, I am writing in green color, this value or this whole voltage value will be our what? Say VB2 is nothing but simply 19.3 volt. So now here we can say that this one is 19.3 and this one is 20. So the difference will be 0.7. Okay, na? Means what I am saying, this voltage is 20 volt, and what we observe, this voltage VB2 is our 19.3. So this voltage is nothing but simply 0.7 volt that I have shown here. Okay, clear? And this one is our Q2 transistor. Clear? So now we know this voltage. If we, now this voltage is VB2. Okay, so now this voltage is known, and this is a Zener diode. We are think like this voltage, and this voltage we have to know the voltage drop across this Zener is 5 volt. So we can find this value, this voltage. So how we will find? For this thing we are highlighting, we have to think about this Zener diode. Okay, so for this Zener diode I am first making, you have to make the circuit part by part, and this value that we have already calculated, their VB2, okay, is same as that of VC2, is how much? 19.3 volt. Okay, this value is 19.3 volt, and this difference, this voltage drop across this VZ is 5 volt. So we can say this value is say VB1. This value is nothing but simply we can say the voltage in this one will be VB1. So VB1 we can find because this one is given, this one is given. So basically this VZ is nothing but simply VB2 minus VB1. Okay, VB2 minus VB1. So this one is 5 volt and VB2 is 19.3 volt minus VB1. So I am writing here. So VB1 equals to, if we to take this side, in the left hand side, VB1 equals to 19.3 minus 5. So 19.3 minus 5 is 14.3 volt. Okay. So this one is our VB1. So the value of VB1 is now 14 point, this value is our 14.3 volt. Okay, 14.3 volt. This one is our 14.3 volt. So now this value is known to us, 14.3 volt. Okay, and I1 and the corresponding IZ. IZ is also given, that the IZ value is how much? IZ 25 milliampere. So this one is 25 milliampere current. So we can assume that the IB current in the circuit IB1 is nearly zero. Okay, so all the diode current, Zener diode current will go through this resistance RZ. Okay, so what we are assuming? We are assuming that IB1 current is nearly zero. Okay, so IZ current will flow from resistor what? R1. Yes or no? So the I1 is nothing but simply IZ, and this one is 25 milliampere. Okay, so now what we will do, we can find directly now R1. So this value is what I am writing here, R1, and this voltage now is known to us, 14.3 volt. This one is ground, so make it ground, and this value is known to us, that is our 25 milliampere. So what we can write, R1 value will be 14.3 minus 0 by 25 milliampere. Okay, or we can write 14.3 by 25 into 10 power 3. So if we solve this one, R1, 14.3 divided by 23. Okay, so it will come nearly 0.572 kilo. Okay, means what we are doing, means here Once again I am showing. This one is some resistance, say VP1, and this one is ground, and this one is some resistance R1, and this current is given I1 or IZ, I1 equals to IZ. So this current I1 can be written as higher potential minus 0 ground by R1 V equals to IR. So like that we can easily find the value of R1. Okay, yes or no? So now R1 is now known to us. What we are doing? Just we are finding the voltages and we are just trying to solve this concept. Okay, means now it is clear. Now we have to find out the value of R2. Is it clear now? This value is 14.3 volt. Okay, 14.3 volt. This one is 0 volt. So 14.3 minus 0 divided by I1, that is our IZ, 25 milliampere. So if you solve R1 value will be automatically we will get this. Now we have to find out for the R2. Okay. So once again, the same circuit I am taking here. Okay. So once again, this one is our 20 volt. Okay. So now we have already find this value. Once again I am writing from my starting. This one is our 20 volt. Okay. So what should be the value? 19.3 volt. So that's why this value will be 0.7 volt. Now this all is 19.3 volt in this one. So this one is 19.3 volt. Okay. So this value will be what? BZ for 5 volt drop. So 19.3 minus 5, 14.3 volt. Okay. So now I1 will be simply this one is same as that of IZ, that is our 25 milliampere. So R1, the value of R1 we have calculated 14.3 minus 0 by 25 milli. So it is 0.572 kilo. Okay, very clear. Yes or no? Now we have to find out the value of this one. So this value we know 14.3 and this drop is also 0.7. So what is the value of this one? This value is what? VE1. Okay, means now we have to find the value of R2. So what we can say? The value of VEB1 is 0.7 volt. It is given. So this can be written as VV1 minus VB1. VB1 we have already known 14.3. So 0.7 equals to VE1 minus VB1. VB1 is this one 14.3. So VE1 is nothing but simply 0.7 plus 14.3. Simply 15 volt. Very simple. VE1 is 15 volt. We could also write directly because this one is 0.7 voltage drop. So this value must be 15 volt. Is it okay or no? Is it okay or no? This value will be 15 volt because this one is 14.3 volt. So this should be 0.7 volt. Okay. So now we are assuming that the now we are what we are saying the current in this one. Okay. The current in this one is IB1 is nearly 0. We are not using beta is given, but we are not using. Okay. And IL value is given. IL value is given how much? IL is 12 milliampere. This one is our 12 milliampere. So IB is nearly 0. So what we can say, this one, that is our IE1 is nothing but simply IL, that is our IC1. IC1 is nothing but simply our 12 milliampere. So the in this one 12 milliampere current is going and this one is 0. So this one is a 12 milliampere. So we have to find the value of R2. So this voltage is 20 volt and this voltage we have calculated 15 volt. So this one is R2 and this current that we are that we know that is our 12 milliampere. Yes or no? So R2 can be easily find. So R2 can be easily find like higher potential 20 minus 15 by 12 milliampere. So 5 by 12 into 10 power 3. You have 10 to the power minus 3. So it should be around 0.4 into 10 to the power 3. Okay, means 0.4 kilo ohm. Means what I am doing? Once again, if this one is some resistance R2, this one is say potential like VCC, and this one is our VE1, and this current is say IE1. So what we can write? R2 equals to higher potential VCC minus VE1 divided by IE1. Okay. So like that we have find the value of R2 value. Okay. 20 minus 15. 20 minus 15 by this. So it should be 0.4. Okay. Here we know now this voltage 20 volt, which is this value to 15. So I 20 minus 15 divided by 12 milliampere. So R2 value, this it is around 0.4 kilo, and this 0.56572 can be 0.6 kilo ohm. So the answer, so R1 R2 now we know the R1 value is 0.6 and R2 value 0.4. So the correct answer for this question will be option number A. So this is all about this question. So this is a very simple question. Some value that we have not used like beta and all, but only we have to very careful about the voltages. If we know the voltages like 20 volt, 14 point 19.3 volts, 0.7, so this voltage is given because we are assuming this one as a 0, and like that if we find what we will get R1 value 0.6 and this R2 value 0.4 kilo ohm. This one is kilo ohm. So R 0.6 and 0.4 kilo ohm already given. So this is all about this question. So thank you for watching this video. Thank you.